Welcome to Microsoft Build 2017. I'm Andrew Whitechapel. I'm a program manager on the App Platform and Tools team. And today I'm going to talk about a new set of diagnostic APIs that we're introducing. So we'll look at the new APIs, what they are and what they do, and how they map to how the system understands apps. And then we'll spend some time building a UWP version of Task Manager, which is one of the ways that you can use these APIs. So what are the APIs? How are they different from what you've already got and what's actually available right now? So what they're for is to provide diagnostic information about running apps. That's all running apps, not just your own app, but any running app. And we had two use cases in mind when we designed these APIs. One was to provide support for general purpose tooling. So you can imagine you could build an app that is a developer tool, an app that you could ship in the store that would monitor other apps, that would provide profiling of other apps, that would provide diagnostics about other apps. And then the second use case is for app developers who are not really interested in other apps, they're interested in their own apps. So they're building an app and they want to build a test harness or a profiling harness that provides a bit more diagnostic information than what they can already get and is targeted specifically for their app. So you already have some diagnostic tools obviously available to you. I mean, for the general purpose case, you have things like Task Manager, which will get you a list of running processes, and it will get you information about those processes, like the memory usage and the disk usage and so on. And then in Visual Studio, you have some diagnostic tools like the memory profiler and the CPU profiler, which already get you dynamic tracking of memory usage, and they're excellent tools. So what are we bringing to the table that's different? And the answer is that all of the existing tools are process-based. That is, that they understand about the process. They can give you the diagnostic information about the memory usage for the process, for example. But they don't know about the additional UWP-specific information. So a classic example is a developer will say to me, well, I'm debugging my app in Visual Studio and I've got the memory profiler running, and according to the memory usage chart, it's telling me that I'm well below my memory cap, and yet my app is still crashing with memory allocation failures. And why is that? And the answer is that the VS memory profiler and Task Manager, they know about the process. They know about the process's memory, the memory that's in use attributed to that process. What they don't know about is the shared memory that the process is also using because it's being shared amongst multiple other processes. And the decisions that the resource manager in the platform makes about memory caps, for example, is based on a combination of the private commit that the app is using that VS knows about and the shared commit that the app is using that VS doesn't know about. So these APIs give you the additional UWP-specific app information, the package information, and also the runtime information. So you can supplement the existing Visual Studio tools with these APIs. Can you use them now? Yes. We shipped a very, very minimal version of these APIs in the Creators Edition. So you can use them right now. If you think about what we're doing, we're exposing information to a UWP app about other UWP apps or other apps in general. And that's something we've never done before. So for the Creators Edition, we focused on building the infrastructure so that this would actually work correctly. And we only released a very, very minimal set of data on top of that. So you can use the APIs now, you can get a list of running apps, you won't get very much information about the apps. But in the upcoming release, we're obviously fleshing out that information so that there'll be more data that you can get, more interesting types of data that you can get for the running apps. And in this session, we're going to look at both. We're going to look at what you've got in the Creators Edition and what's coming up next. So the primary class in the new API is the App Diagnostic Info class. And this will tell you what apps are in memory. It will tell you their execution state. Are they running, suspending, suspended, not running? And metrics about the resource usage, as I said, the memory usage, including the private and shared commit, the CPU usage, the disk usage, energy, quota, status, and so on and so forth. We've also integrated them with some existing APIs. The process diagnostic info, for example, is an existing API. It's been around for a long time. But we've integrated the app diagnostic info with the process diagnostic info, so you can get both sets of data in the same place. We've updated the process diagnostic info so that it knows about the app diagnostic info. And similarly, the memory manager class, which you can use right now, that gives you memory information about your own app, but it doesn't give you information about other apps. So we're using that same information source to provide you information about other apps. And because we're exposing information about other apps, we thought about this very carefully. And so we're protecting this API with a restricted capability tied to user settings. And we'll see exactly how that works when I walk through the demo in a second. So here's an example of the sort of thing you can do with the Creators Edition. You can see this is pretty much the information you can get, not very much, not very useful right now, admittedly. But you can see for each app, I'm getting the logo, the display name, the app user model ID, the package family name, and a few other things like that, which isn't on its own terribly useful, but the key point is that you are getting a list of other running apps, which you've never been able to do before. So I'm going to switch to my other machine so we can have a look at the code and get this running. Just F5 that. As it's building, let's look at the code. You can see in this app, it's very, very simple. I've just got a data bindable view model collection up there, an observable collection of row info. My row info class, my view model class, it's dead simple, just the logo, display name, app user model ID. And then what I'm doing is I'm calling the app diagnostic info request info async. And that gets me back a list of app diagnostic info objects for all running apps, for all running UWP apps and desktop bridge apps. And then I'm iterating through this collection. So for each one, I'm saying, okay, just construct me a row info view model object based on the interesting things in there. Let me switch back to the code just for a second. So I'm pulling out data like the display name, the logo, the app user model ID from this app diagnostic info. So when I run the app, as you can see, just size it for this screen. I just hit the Get Data button, and what's going to happen is that it's immediately going to throw up a user consent prompt, because we very much want the user to be in control of this. The API lets you get information about other running apps. So we want the user to know that this is happening and to give you permission to do this. And so the user can choose, this user prompt will be thrown the first time they run this app that tries to use these diagnostic APIs. So I'm going to say yes, and then it's just going to populate the list with this diagnostic information. As I say, not terribly interesting diagnostic information just now, but it is a list of everything that's all the UWP apps that are running. And let me just show you quickly in the settings app that the settings that the user has just set in that consent prompt are down in the privacy settings. So way down at the bottom of the list, there's an app diagnostics section. And you can see there's basically two sets of toggles here. There's a global one at the top that says, yes, in general, apps can use app diagnostics. And then there is an app-specific list. So each app that's actually trying to use the diagnostic APIs will be listed in here, and you can turn them on and off individually. Or you can turn everything off globally so that nobody can use it. So the user can always come back in here, regardless of what they said in the user prompt, they can always come back in here and change their minds if they want to, so that they're always in control. So it's just a summary of what we've just seen. As I say, you call the request info async from the app diagnostic info to get the data. Oh, and manifest capabilities, I should have called out when I was looking at the sample code, but the app that uses this API must use this restricted capability, the app diagnostics restricted capability. And that ties into the user prompt and the settings page. So none of that works unless you have this in place. And the API itself won't work unless you use this. And what the additional thing that this does is that if you submit an app to the store that contains this, then it undergoes some additional scrutiny, because we will only approve this request to use this capability and to use these APIs if the app is clearly a developer tool app. So if it's in the developer tools category in the store, and if it's clearly doing debugging, profiling of apps to support development. So you can't just submit a random app that happens to want to use these APIs. It has to be a developer tool. So here's what's available now as opposed to what's coming up next. The App Diagnostic Info class is already available in the Creators Edition, and you already get the app info and the display info, which is the package level metadata, which is basically a set of strings, the name, the ID, and so on. What we're building right now is the resource group info. So each app diagnostic info will have one or more resource group infos, and it's the resource group info that encapsulates the detailed diagnostic data that you're really interested in, which is the memory data, the CPU data, the execution state, the energy state, the list of background tasks, and so on. And it's called resource group info because it relates to how the platform manages components within an app. So in your app, if you're using resource groups, if you've declared resource groups in your manifest, then these will directly correspond to the resource group infos that you get back. Otherwise, you'll just get a default single resource group info. So here's an example of the same idea of a task manager, but it's using the next release of the APIs, so beyond the Creators Edition. And let's have a look at the differences in the API. So what I'm doing here is I'm actually getting a list of not just the UWP processes, but all processes on the system, which is what Task Manager does. So instead of starting with an app diagnostic info, I'm starting with a process diagnostic info. So I'm saying, get me a list of all the process diagnostic infos. And then get the interesting data out of the process diagnostic info. And if this particular, as I'm iterating through the list, if this particular process is a packaged process, if it's associated with an AppX package, in other words, if it's a UWP or it's a desktop bridge app, then there will be additional app diagnostic info available. So then I can go off and go and get that and get the additional data metrics from the app diagnostic info. So let's have a quick look over on my other machine. I've got another example here. This is my next release version of the APIs. This is my task manager that's using the beefed up APIs that are getting more interesting diagnostic data beyond just the names. I should probably use my mouse, that might help. So looking at the, actually let me build it. Looking at the code, the first thing you'll notice is that there's a separate request permission. So we've abstracted out a method that allows you to do the user consent prompt. So previously, or in fact, it's still true that any use of the app diagnostic APIs will trigger that user consent prompt on first launch of the app. But we felt it would be useful to pull that out so that you could do that separately up front, separate from where you're actually gathering the data. And you can imagine that you might gather the data sort of iteratively in a loop. I mean, using a timer perhaps for polling. But you can see that I've got this in my on-navigated too, so it's immediately throwing up the consent prompt. Let me just go back to the code for a second, just to give you a high-level view of what we're doing in here. So there's a Get Data button. When the user clicks that, I'm getting a list of process diagnostic infos. And for each one, I'm then going to populate, again, I've got a very simple view model class here, and I'm going to populate that with the process information. And then if it's packaged, I'm also going to go ahead and get some app diagnostic info, and then continue to populate that same row info with the additional app info. If we look at the process info, it's what you would expect. I'm getting a process diagnostic info, so I can get things like the memory usage report, which gives me interesting things like page file size in bytes, working set size, the page count, the peak working set, the peak page file size, and so on. There's about a dozen different fields in there that are interesting for memory. Same thing for CPU. I can get a CPU report, I can get a disk report. I'm getting that information and putting into my view model. And then, as I said, if it's packaged, I'm also going ahead to get the app information, which is getting the app diagnostic info, getting the resource groups, because there'll be one or more. For a running app, there'll be one or more resource groups. And for each of those, I'm getting whatever is interesting to me, like the memory report, for instance, which includes both the private commit and the shared commit. And I can get a state report, which tells me, is it running, or is it suspending, or is it suspended? I can get the energy quota report, I can get the list of background tasks, and so on. So you get the idea. So back in the app, I'm just going to say yes to this. And then I'm going to, so that's given me permission to use the APIs, which means that when I try to get the data, hopefully I will actually get some data. So I'll hit get data. And you can see from the size of the scroll thumb how much data I'm getting. This is everything that's running. This is all processes, Win32, Desktop Bridge, UWP, including system services, system apps, all sorts of stuff. So as I scroll down through this, these are mostly Win32 apps. Eventually I start to see some UWP apps. And you can see the difference. I mean, here's a Win32 app where I'm getting interesting stuff like the process ID, the executable name, the private commit. I'm not getting the app user model ID because that doesn't exist for a Win32 app. I'm not getting the total commit because that includes the shared commit, which is not tracked for Win32 apps. The execution state is unknown because that's also not tracked for Win32 apps. Compared to a UWP app where I am getting that additional information. And I should even have down in this list the app that I'm actually running should be in this list somewhere. There it is, Task Monitor Next, with its process level metrics and also its UWP additional information. So to summarize, we've introduced a new set of APIs that will give you diagnostic information for any running app, and you get varying levels of information depending on the type of app. It's protected by a restricted capability and a user consent and user settings. There's two types of data you can get. There's the process data and the additional UWP app data. And the intent is to support people who are building either general purpose developer tools or for somebody who's building an app and they just want to profile their own app. So we've looked at the developer tools approach in this session, and we'll look at the targeted profiling approach in the next session. Call to action, please join the Insiders program to get early release of early access to builds and early access to the newer set of APIs as we flesh them out. You can start using the APIs right now, even if you don't join the Insiders program, but as I say, the data you get back will be fairly minimal. There is sample code on Git, which will be there very shortly. And please provide feedback on user voice. Any comments, any questions, anything that's missing, any additional diagnostics that you think would be useful to have, that would be good to tell us. And that's it. Thank you.